They says the universe is governed by the rules, invisible laws that dictates the movements of planet, the burnings of stars, the very nature of existence itself. But what if there were secrets burned within these laws? Secrets so profound that even the greatest minds struggle to comprehend them. Today and tonight, we journey into the forbidden realm of the atom, where reality itself was written by two men, Wolfgang Pauli and Satyendra Nath Bose. This is their story. Welcome back to the series in the name in the search of shooting a cat, in which we are telling you the quantum mechanics in a way of story by which you can easily understand what I need to say and how this happened in the past and how this quantum series make a difference in the reality of world. So be with me in the story in which we explore the Pauli exclusion principle and the Satyendranath Bose and Einstein work. Okay, so be with me in the story. So story begins with this: Wolfgang Pauli, a genius, a rebel, a man who never expected mediocrity. His tongue was as sharp as his mind, and his intellect cut through conventional physics like a scalpel. If there was something wrong with a theory, Pauli would tear it apart with mercy. But despite his brilliance, he carried a burden, a puzzle that no one had solved. Why did electron behave so strangely? And how? Why couldn't two of them occupy the same space with an atom? I explain it properly. Was the question about the Pauli? Like in the hydrogen, you see the outer line of the neutrons, middle heavier nucleus, and then we have outer line of two electrons. And why? Pauli says why we have only two electrons in the outer shell, the first shell of the nucleus. Why we have only two, and then there are greater shells, and the number of electrons is increasing. Why this is happening? Why electrons behave like this strangely? So, it's incomplete. It doesn't explain the anomaly I have been observing. There's something missing, something fundamental. Electron only obey our law we haven't discovered yet. And I intended to find it. Okay, and find it, he did it. What came next was a revolution, a rule that would forever shape quantum mechanics, the Pauli exclusion principle, a simple yet profound idea. Now, no two electrons in an atom can occupy the same quantum state. This rule dictates the structure of periodic table, the formation of matter, even the fate of Kolaskin's collapsing star. But at the time, Pauli had no idea just how far his principle would reach. So, at the first, he was taught that the two electrons in the same orbit cannot occupy the same state of quantum. So, what he said in this, okay, but he have no idea that what he was saying right now at that moment, okay, and how this react, how this idea react on the quantum field and quantum mechanics and the quantum world. So, what happened next? On the other side of the world, firstly, on the other side of the world, another mind was working on a different kind of mystery. And his name is Satyendra Nath Bose. You all know that. You read in the science books and in the studies of school, colleges, and other laboratories in the science field, in the quantum field. A man whose name would one day be unattended in the some breath of Einstein's. But at this moment, he was just a professor in India struggling against the tide of Western scientific domains. Boss had an idea, one that would challenge everything know about light and matter. Photons. They don't behave like particles. They act like an collective as if they are indistinguishable. Indistinguishable. Sorry for misspell. Boss has stumbled upon something extraordinary. Listen to me. A statistical method that describes how particle of light photons clumped together instead of behaving like individual entities. It was a revolutionary concept, but no one in India would listen. His only hope is one of the great scientists in the 90s, early 90s, Einstein. So he said, "Dear Professor Einstein, I hope you will not be affected by my boldness." And so, Boss sent his equation across the ocean, hoping the greatest mind of the 20th century would recognize their worth. He had no idea what fate had his store. Okay, so Einstein saw the genius in Bohr's work. He took it further, applying the same idea to the atom themselves. What emerged was the Bose-Einstein condensate, name Bose-Einstein condensate. Firstly the Bose and then the Einstein. That's the real thing about the Einstein. Okay, he took firstly the Bose work and then their work. Okay, a state of matter unlike anything seen before, a realm where particles lose their individuality. Okay, merging into a single quantum wave. It was an era, almost supernatural phenomenon, and it sent shockwave to the scientific community. Okay, a new state of matter, something beyond solid, liquid, gas, or plasma. The fourth state of matter. You know about plasma, okay? Like a form of a liquid or gas of kind, like a wave form. Okay, a fifth state is now formed, the key to unlocking the mystery of the universe itself. Okay, so back to the Pauli. Now staring at a set of equation. Okay, two minds, two worlds, two groundbreaking discoveries. What Pauli had theorized about matter, Bose and Einstein has uncovered in energy. They both are in the different field, energy and matter, but they are connecting each other at a single point. Okay, so the exclusion principle dictated how matter was structured. The Bose-Einstein statics revealed how it could unify. Okay, opposites get connected. Okay, and from this, yeah, and from this union emerged a deeper truth. The universe is divided into two fundamental phenomena and two fundamental types of particles: fermions, which obey Pauli's law, and bosons, which follow Bose. One builds structure, the another enables unification. It was the cosmic balance, the fundamental blueprint of existence itself. Today, their discoveries shape our world in a way that we never had imagined. Every atom in our body follows the rule of Pauli exclusion principle. Every laser, every superconductor, every quantum computer follow or is built on the foundation of Bohr's work. They were not just a scientist, they were extratists in the reality. Okay? And yet, the mysteries of the universe remain unsolved. What else weren't wait to be uncovered? What other lock, what other laws lurk in the shadows waiting for the next Pauli, the next Bose to bring them into the light? So that's about the Pauli exclusion principle and Satyendranath Bose and Einstein work. So I hope you enjoy this series and we'll meet in the next video with another story, another topic, and another like experiment and elements in the quantum world. Be with me.